Hi, what is the most likely outcome of a binomial distribution X with parameters n and p? Show that as n goes from 0 to n, p of x equal to k increases monotonically, then decreases monotonically. So let's first start with the probability distribution for the binomial distribution. You write it as p of x equal to k. It's equal to n choose k times p of k 1 minus p to the n minus k. Okay, so intuitively, I think we have seen how a binomial distribution look like. So let's start with some example. N equal to 6, p equal to 2. So in this example, we're imagining like 6 coin flip, a fair coin flip with probability half a head, half a tail. So then the variable x will represent how many times a head will come up. So probability of x equal to 0 is n choose 0, which is 1 times 1/2 to the 6, which is 1 over 64, sorry. And it's actually the same as probability of x equal to 6. So basically, getting no heads or getting all heads is the same. And then probability of x equal to 1 would be 6 times 1/2. So you can 5. So 6 over 64. And actually by symmetry, this is equal to x equal to 5. I mean, one of the reasons, as you can see, is because n choose k, it's always equal to n choose n minus k. X equal to 2. In this case, will be 6 choose 2. I'm just gonna, oops. Do the math, it's gonna 64. 15 over 64, just same as x equal to 4. Finally, 6 choose 3, just too lazy to write out the whole thing, which is going to be 20 over 64. So graphically, it's going to look like 1 over 64, 15 over 64, sorry. So this is like 0, 1, 2, 3, 4, 5, 6. This will be 20 over, right. So in this case, the maximum is going to be at 3. And we can just observe that it does increase monotonically as k. So this is the k-axis. I mean, increase monotonically going from 0 to 3, and then decrease monotonically going from 3 to 6. Okay, so what we can do is we can observe the ratio between probability of x equal k divided by x over equal to 1 minus k. So when this is greater than 1, that means it's increasing. And when it's less than 1, it's decreasing. Since we always know both numbers are always positive. Right, so let's write it out. The numerator, we have n choose k over p of k, 1 minus p n minus k. Denominator, we have n choose k minus 1, p of k minus 1, 1 minus p of n minus. So instead of k, we are putting in k minus 1, so that will be k plus 1. Right. Okay, now let's expand the combination into factorials. K factorial, n minus k factorial, p of k, 1 minus p, n minus k, n factorial, k minus 1 factorial, n minus k plus 1 factorial, p of k plus 1, 1 minus p, n minus k plus 1. Alright. So now the n factorial cancels out. The k factorial and k minus 1 factorial, it will cancel out to be 1 over k. And then in the denominator, it cancels out to be 1 minus k. And on the other side, p, oops, I should just realize I made a mistake here. Should be n minus 1. So the p would cancel out, and also same for the 1 minus p. And this we can flip it with n minus k over k. Sorry, not a mistake. This one should be plus 1, because when this factorial cancel with this factorial, the n minus k plus 1 will be the last factor remaining. That's p minus k. So basically, the only variable we have is k. So let's try to get it to one side. So we know that this variable, if it's greater than less or greater than equal to 1, it will make it increasing. So you can factor out k. We do it by multiplying out everything. np minus kp plus p greater than equal to, and we multiply both of the denominator to the other side, which will make it k minus kp. The kp cancels out, so it will be n minus 1 p greater than equal to k. So that means when k is less than 1 over n minus 1, it's n plus 1. As you can see, it's since we are, actually let me change the color. We are cancelling out this and this one. We are left with np plus p, which is n plus 1 over times p. Go back. So that will be the criteria when k is increasing. So when as k goes from 0 to n plus 1 times p, it's increasing. And when k is past that point, so when k is greater than, it will be decreasing. So there you go.